Hello again. Thanks for joining us. This is Space Nuts. My name is Andrew Dunkley. Thanks for joining us. Coming up on this episode, we are going to be looking at a rather amazing achievement involving an organisation who have landed on the moon. And you're saying, yeah, well, it's been done. Not like this, it hasn't. On top of that, we've got a mission that's going past the moon that is in a little bit of trouble as well. We'll also focus our attention on the Andromeda galaxy, and we've had some questions recently about Andromeda. Well, you'll be interested to know that it has been suffering from interference, and it wasn't us. It wasn't. We didn't do it. And Voyager 1 back in the news again. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he's back in the big chair after a month away. It's Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Good to be back. The politicians always say, good to be with you, don't they?
Yes, they do, don't they? Yes.
Good to be with you.
Yes. I'm sure they sit there with consultants and committees waiting the right way to say hello.
Yes, that's right. And the answer is good to be with you.
Good to be with you. Now, we talked on the last episode or two when you popped in on us about your trip north. One thing I wondered is while you were there to look at the Aurora Borealis and the like on an astronomy tour, did you actually get to see the planetary alignment, or couldn't you view it from that far north?
We could, but you're right. It's a good question because the ecliptic, which is where all the planets lie, just like the equator, the celestial equator, is very low down at the latitudes we were at. The furthest north we got was to North Cape, which is 71 degrees latitude. A lot of the time we're in Greenland. Iceland's a little bit further south. It's only the top, really, the north coast of Iceland that's within the Arctic Circle. But we're also well in the Arctic Circle in Sweden and Norway. North Cape, of course, is in Norway. So, yes, your view of the skies is different. What always, and I remember being struck by this in my very, very first visit to the Arctic, which was back in 2012 when we led our first expedition up there. And I was struck by the fact that I could see stars, which from our latitude and I'm still thinking of the Northern Hemisphere, from the latitude of the United Kingdom, were only visible in the summertime. And we were there in the middle of winter. So you can see at least two stars of something called the Summer Triangle. The Summer Triangle is Vega, Altair, and the brightest star in Cygnus, which is Deneb, Vega, and Altair. Vega and Deneb were very, very visible in midwinter near the North Pole because the pole of the sky is tilted upwards. So you can see things that from kind of middle latitudes you'd only see in summer. So what it meant was, yes, your question is well made. We certainly saw Venus, Jupiter, and Mars very clearly. Probably Saturn, although it was quite near the horizon then, and I don't think we got a glimpse of Mercury. So that parade of planets that really occupied the media for us in the Southern Hemisphere, it was actually best back in January.
Yeah,
it's only in the north that it's been a hot topic within the last few days.
The reason I ask is it's been in the news again because they said that, the popular press is saying, the big alignment, last time we'll see it in 60 years, blah, blah. Jonty has a particular problem with the way the media spews this kind of information out and don't let the truth get in the way of good story type of attitude.
That's right.
But it was, apparently it was the whole set at the end of February because Mercury was part of the deal then.
From the Northern Hemisphere.
Yeah, well, there you go. And I was just wondering if you got a chance to spot it. But
no, didn't see Mercury.
No, I didn't see any of it much.
Okay.
I did go out and look, but where I am in town, it's a really bad position, and I'd have to go out and find a hill. And as you know, there are not that many of them around here.
No, you're a bit low on hills up there. You need somebody to come and build one for you.
Yeah. Yeah, or just cut all the trees down. And
well, there's that too, but that's not a good idea.
no, not really, no.
Yeah.
Okay. All right. Let's get on to our first official story. And this one is very exciting and again, getting a lot of press. And that's been the successful landing of the Blue Ghost Lunar Lander on the moon. This is a lot different to what we were witnessing in the 60s and 70s and a few of the more recent missions, because they were publicly funded and government gazetted and all that jazz. This is a completely different kettle of fish.
Indeed, because it is a commercial space flight. It's a commercial company with the lovely name of Firefly Aerospace. Their Blue Ghost Lander is named after a rare species of firefly, which is found in the Appalachian area of the United States. I love the name of the mission. It's not Apollo or Artemis or anything. It's called Ghost Riders in the Sky.
I love it.
And we did see earlier in the week, before the spacecraft landed successfully, which it did on March the 2nd, Eastern Standard Time, Sunday at the weekend just gone. We did see some images during the week from the navigation cameras, which showed the Earth and the Moon as the lander flew by. But the reason why this lander is going to the Moon, or has gone to the Moon, is that it's part of something you and I have talked about, Andrew, NASA's Commercial Lunar Payload Services Program, CLPS, Commercial Lunar Payload, which basically is NASA contracting to private companies for payloads to go to the lunar surface, either experiments or well, I suppose they're all experiments, or at least things that test the technology, basically to check things out before the Artemis mission really gets underway with a lunar landing. We hope that Artemis will see humans walking on the moon 2027, I think, is the current date, but that could change because all sorts of things are happening inside NASA, which we really didn't expect. Anyway, the launch was on the 15th of January, so it's taken a little while to get there. It is the spacecraft rode into orbit on a Falcon 9, a SpaceX Falcon 9, and essentially having gone into lunar orbit earlier in February, 13th of February, it was descended or sent a command to descend to the lunar surface on the 1st of March and successfully touched down on the 2nd. So really great stuff. Fantastic news that a commercial space flight has landed successfully on the moon. Yes,
it is marvelous. And it's a very short mission, though, isn't it? They're not going to be doing much for long, from what I understand.
I think that's right. I think the essential part was just demonstrating that they can get there, which they've now done very successfully. I think it's, as you said, it's a short mission. I think it's one of these things that will only last for a lunar day. I need to check that, but it's that sort of time. It's easy to find some really nice pictures of what the sky would look like for Blue Ghost. There's a very nice picture on X of a gentleman by the name of Buzz Aldrin watching the landing.
Yes, yeah, he sent them a message of congratulations. Yes,
yeah. Which is great, and who better to send a congratulations to a company like that than Buzz Aldrin, the second man to walk on the moon.
Absolutely, yes, and I think I've mentioned before I've had the great pleasure of meeting and interviewing him in my radio career, so that was one of the big highlights for me.
I love one of the highlights for me was having dinner with him.
Oh, that's even better. Yeah.
It was really interesting. We'll talk about that some other time. It was a very interesting meeting, but it was very stimulating. This is probably a decade ago.
Yeah.
It was, a great company, as you know.
Yeah. I notice in one of the stories, I think it's in Sky and Telescope .org, they refer to the descent orbit insertion as 9 minutes of terror.
Yes.
We've talked about these terrifying landings on other worlds, particularly Mars. I wouldn't have thought that it would be as big a deal on the moon, given that there's, no atmosphere of you can
You're
see.
right. Yeah, and you're absolutely right, because, if you're landing on Mars, a lot of the trajectory is dictated not just by orbital mechanics, which is how things work in space, but dictated by the vagaries of the atmosphere. If you've got slightly higher pressure than you expected, you've got more braking force, and suddenly your spacecraft is heading for a different part of the surface at a higher speed than you would want, or lower speed, or whatever. And you're right that in the case of the moon, it's all about orbital mechanics, which are very, very predictable. But you can imagine, you've got to fire those thrusters at just the right moment to brake it so that when it lands on the moon, it doesn't land too hard and smash up on the rocks, or basically bounce off and then smash up. You've got to get things just right. So 9 minutes of terror, I can sympathize with that. I think I'd feel like that too.
Well, when you're talking about braking from 3,800 miles an hour to 90 miles an hour, yes, that would be that would be terrifying if you push the wrong button or the thrusters fail. And I think I had to smile when I read the story, because they said successful landing and upright. So yes. I think they were sort of saying, well, even if it lands on its side, that's a success. But it's even better that it's standing up.
Right. Yes, it was last year, wasn't it, that one of the spacecraft did land on its side?
That's right. I remember. I think it was the Indian mission, was it?
Was it Indian or Japanese? I can't remember.
Yeah.
But yeah, so it was landed in such a way that the solar panels weren't seeing the sun.
Yes, that's right.
So yes, it's very important to have it the right way up.
Yeah. Anyway, we wish them well. It'll be a quick visit, and it paves the way for Artemis 2. We still don't know when that's going to happen. Seems to be getting pushed back time and time again, but they will get there eventually.
I'm sure they will.
One will hope. Let's take a short break from Space Nuts to tell you about our sponsor, NordVPN. Now, I've talked about virtual private networks before and how they can protect you online, and no one does it better than Nord. Now, I've been using Nord for over 2 years, and I have no complaints. I'm also using some of their other tools, including the brilliant password manager and the 1 terabyte of cloud storage. And let's face it, you just can't get enough storage these days. And cloud storage is good because it's backed up. If you've got it on a drive attached to your computer, that drive will eventually die, and you don't want to lose all that stuff. Cloud storage is the way to go. Right now, Nord is offering up to 74% off for Space Nuts listeners, on top of an extra 6 months added on if you sign up for a 2-year deal. That is a brilliant offer. And it's all backed by their 30-day money-back guarantee. Now, the level of discount does vary with the different plans, but the longer you sign on for, the better the deal gets on a monthly cost basis. You just need to work out what's right for you. NordVPN is great for streaming and won't slow you down. In fact, it does the opposite, with no interruptions, no limits on bandwidth, and no limits on speed. And with over 7,000 servers around the world, they've got you covered. So take advantage of their exclusive Space Nuts deal today by going to nordvpn.com/spacenuts and click on Get NordVPN and discover all the options. That's nordvpn.com/spacenuts. The 6-month extra deal is for a limited time only, so check it out today at nordvpn.com/spacenuts. You'll be very glad you did, I'm sure. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, while we're talking about these kinds of commercial missions, there's another one that's in the news. This is a private mission that was heading out past the moon to the Odin asteroid, the private Odin Asteroid Probe. All was looking nominal until recently. Things seem to have gone awry somewhat.
Yes, the comment that perhaps highlights the situation comes from somebody by the name of Matthew Gialish, I think it is, who is the co-founder and CEO of Astroforge, which is the organization that is operating the Odin spacecraft. What he said on Friday, the 28th of February, was we don't fully understand the state of the vehicle. It's thought still, though, to be in a mode that means it's not being fried by the light of the sun. It's in an attitude in regard to the sun that will, not have parts of it being unduly heated, although we believe that it is tumbling. This is not a good thing for a spacecraft to experience. That's one of two alternatives, which I think are still valid, Andrew. One is that the spacecraft is tumbling, which is not nice. Or the other is that everything's fine, but there are issues with the telemetry back on Earth, their ground receivers not being properly configured or whatever.
Yeah.
So they're still basically worrying about what's going on. We should check that story again perhaps next week.
What's the goal of the mission? They're going to visit an asteroid, but what do they want to do with it?
Basically check it out, to send imagery of an asteroid which rejoices in the name of 2022 OB5, and it's a possible first step in basically recovering resources from a space object. In other words, asteroid mining.
Wow.
So if this mission was successful, and we're not sure that that's the case at the moment, this mission is basically designed to focus the cameras on that asteroid 2022 OB5 in order to get a survey of the surface, see what's there, take lots of images, use the filters in the cameras to get some idea of the surface texture and things of that sort, which you can do, particularly in the infrared wave band. But that's a precursor to a second mission. This mission's called Odin. The second mission is called Vestry, which will aim to land on the asteroid. So that's perhaps the more ambitious one that we will be looking at down the track, assuming that Odin pulls it off, or Space Forge pulls it off as far as Odin's concerned.
Yeah, well, fingers crossed. I think this quote from Matt Gierlich, who you quoted earlier, says it all. I think we all know the hope is fading as we continue the mission.
Yeah. I mean, it's what we've always said, space is hard.
Well, it's tough out there.
Yeah.
Yeah, it's a difficult gig, but they keep on trying, and not all missions are absolute failures. Even when they don't go well, there's something to learn, and
there's always something to learn. That's right.
It's better next time. Yes, indeed. And you can read about that story if you like at space.com. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Okay, we checked all four systems and skiing was a go.
Space Nuts.
Okay, Fred, let's head towards Andromeda, or is it heading towards us? Either way. We've had a few questions recently with Jonty about Andromeda, and he was he had a lot to say about it. And one of the questions we got recently was, is the Milky Way already affecting Andromeda? And to a certain degree, not a massive amount, the answer is yes, according to Jonty. But we don't have to do that, because it's now been discovered that Andromeda's being picked on by some little cousins nearby. It's already getting a bit of a dust up, so to speak.
It may, yeah. So this may be the result of something bigger, something that we probably need to know about as well. The bottom line here is you're quite right. The Andromeda Galaxy, we see it in the constellation of Andromeda, obviously, at a distance of about 2.5 million light years. Like the Earth, let me rephrase that. Like the Milky Way, our own galaxy, it's surrounded by a swarm of dwarf galaxies. In fact, about 3 or 4 dozen of them altogether. It is those dwarf galaxies, we call them satellite galaxies because they are satellites of Andromeda, have been analysed to death in some new research that's been carried out using the Hubble Space Telescope still, after 35 years, still doing a very, very fine job in giving us spectra and images of distant objects. So the researchers have used the Hubble essentially to map the motion of these dwarf galaxies, which is an extraordinary thing to be able to do, and look at their position in 3 dimensions around the Andromeda galaxy. And it's comparing what they found with what we know from the dwarf galaxies that orbit our own. And it's probably a similar sort of number. It's about 24, I think, satellite galaxies that we have. The biggest 2 are the Large and Small Magellanic Clouds. So you take all that, you build a map of where these galaxies are around Andromeda, and you find that they're in quite different orientations from what we find in our own galaxy. One of the comments in this story, and this is coming from some of the researchers, in fact, Daniel Weiss of the University of California at Berkeley has basically pointed out that something significant has happened to Andromeda to change the distribution of these satellite galaxies. Because half of them, rather than sort of swarming around like, moths around a flame, half of these galaxies are actually in a plane. They're basically in one plane of the space around Andromeda, and they're all going in the same direction. And that is, as Daniel Weiss says, that is weird. He says, it was actually a total surprise to find the satellites in that configuration, and we still don't fully understand why they appear that way. Another colleague says, this is Alessandro Savino, says it's a clear indication of how small galaxy growth is disturbed by the influence of a massive galaxy like Andromeda. And I think the bottom line here is that they've got much younger stars in them. These dwarf galaxies formed their stars very early on in the history of the Andromeda galaxy, which probably goes back 12 or 13 billion years, and then kept on. And the idea is that the perhaps, and they say that they really don't know what's happening, but perhaps there was a collision between Andromeda and another galaxy some billions of years ago, which caused this peculiarity of the dwarf galaxies surrounding Andromeda. Everything about it is weird, including my account of it. Just
so they're saying it's weird. They say they don't really know what happened, but it would have to be some kind of gravitational effect or interference, wouldn't it?
Yeah, I think you're absolutely right, and I think that's probably what they're looking at. As they try to understand how you can end up with a set of something like 15 or 20 dwarf galaxies, all of which lie in a single plane. That flies in the face of everything we understand about dwarf galaxy formation. And certainly is very different from what we find in our own Milky Way galaxy.
And from what I can tell, they've tried to figure this out using computer simulations, and it didn't work.
Yeah. So there you go. And that's just basically telling you that you need to put something else into the simulation, and maybe it is a collision with another large galaxy, something else that's not in there already, to try and replicate what we see in the real world. So
could that mean that if there was a collision with another large galaxy, that the result is Andromeda?
Yes, that's, I think, what you'd have to agree with that. It's not been the collision between Andromeda and the Milky Way, when it happens in 3.5 billion years or whenever it says in the diary that's going to happen, that changes the shape of both of them. It basically, you get a collision, all the shock waves, gravitational shock waves, cause formation of supernovae, basically form really big stars which last only a short time, then explode as supernovae. That uses up all the gas in the galaxies, and you end up with what we call Milkomeda,
Yeah.
the Milky Way Andromeda combination, which looks more like what we call an elliptical galaxy, a galaxy with no gas, no star formation. And Andromeda now is not like that at all. It's a actively star-forming galaxy. So the suggestion is that maybe it was a smaller object that caused this disruption to the satellite galaxies.
Is it classified as a spiral galaxy?
Yes.
Yes.
It's a spiral, definitely.
Okay. And so is ours. But when they get together, they're just going to be boring.
Yeah, they will. They'll be shaped like a football with no spiral arms, nothing happening, nothing to see here.
Yeah. It's a bit sad, really. I mean,
So yeah, because they're both pretty smart looking now.
yeah, what a pity. Oh, well,
Sure.
we can't stop it. We'll just have to put up with it when the time comes. How long? 3.5 billion?
Yeah,
Yeah.
it's something to look forward to, with trepidation, perhaps.
Yes, eventually. All right. That story is at cosmosmagazine.com if you'd like to read up on that one.
3, 2, 1.
Space nuts.
Fred, let's go and visit an old friend, someone who we thought had stopped writing to us. We don't know what we did wrong, but they have reached out to say, hello, I'm still here. I'm alive again. Voyager 1.
Yeah, that's right. 20, I looked it up the other day, 25, is that right? Yeah, no, 20, about 27 billion kilometers away. And the most distant human-made object. I think it's got 22.5 light hours of travel time for the commands. So basically the story goes back, in fact, to the 20. I think I can't remember what date it was, but it's back in November 2023. So it's well over a year ago. That the transmissions started coming through in a gobbledygook format. And there was, I think, an issue with one of the memory chips. And, there was work done on trying to fix that, which basically I think took 5 months or so. And then was it in April 2024, there was a successful receipt of data, and that the machine was sending back things that you could actually read rather than just gobbledygook. So that was back in April 2024. But I think there's been another loss since then. And the difficulties that Voyager 1 has are to some extent ongoing. But there is, it's good news that at least we are still in some sort of communication with Voyager 1. And hopefully there's still potential for intelligible signals to come back. The really interesting thing, I guess, is the power supply, which is the radioisotope thermoelectric generator, which is now delivering a tiny fraction of what it delivered right at the beginning of the mission in the late 1970s. And so we've got an issue there. And what NASA has done is switched off various instruments progressively so that things like the magnetometers that record the magnetic field and things like that, I think they are now switched off so that you're saving power just for pointing the antenna, which is done by the spacecraft's thrusters, and essentially sending signals backwards and forwards.
Yeah, it's quite remarkable, though, after all these decades, that it's still going. We still communicate with it. We can still send it information.
Yes.
And, of course, Voyager 2 is still out there and still going strong, although it, too, has had some issues. Although I think the most recent big issue with Voyager 2 was July 2023, when a series of commands were sent to the spacecraft, causing its antenna to point away from Earth. I think we did talk about that.
We did talk about it, that's right.
And it stopped the spacecraft from receiving commands or sending data back to Earth. And I think they managed to somehow circumvent that I believe it involved the Canberra Deep Space Communications Complex.
Yeah, I was just going to mention that, in fact, it must have done, because that Canberra Deep Space Complex, the Tidbinbilla dish, as we call it in the trade, is the only antenna on Earth that can actually communicate with Voyager 2.
Oh, there you are.
And that's because Voyager 2's at a latitude, if I remember rightly, it's about 66 degrees below the equator in terms of the direction it's going out to, which makes it invisible to the other two stations in the Deep Space Network, which are in Madrid and Goldstone in California. So, yes, only Tidbinbilla can see Voyager 2.
Yeah, and that's how they saved it. They picked up a very faint signal.
Yeah, that's right.
NASA was able to transmit some corrective data, to Voyager 2 and got it back online, which was very good news. And Voyager 1's now back with us, so they're both still going. They're both still talking to us. We didn't.
Quite extraordinary.
We thought we'd offended both of them, but no, it's all good. I mean, they've been alone for so long. I can understand them being a bit grumpy.
Yeah. They might like their own company, though, Andrew. They've both got music to listen to. So
they're going different ways, aren't they?
Yes, they are. That's the thing. Voyager 2 is heading much more to the south than Voyager 1 is.
Yeah. But it's such an amazing story for both of them to. I mean, how far past end of mission have they survived? It's extraordinary. Yeah,
decades. It is. It's fantastic, and they eventually their batteries will run out. Those radioisotope thermoelectric generators will fizzle out, so that they can't even send power to the transmitters. But the spacecraft will keep on going, because they are getting better orbital mechanics, maybe for billions of years. We just don't know.
Yes, until someone catches them in a Venus flytrap on some other planet and it's all over Red Rover. Who knows? Great story about Voyager 1. You can find that online. There's quite a few news stories about it.
Can I just add one comment? So the Canberra Deep Space Communication Complex is 60 years old this month.
Wow.
There you go. I should have remembered that.
Yeah, you did.
Yeah. Should have remembered it earlier. 60 years old this month.
Yes. It took you 60 years to remember that.
Yes.
All right. We are just about done. Thanks for your company. Thank you, Fred, as always. We'll wrap it up and we'll catch you on the next episode.
It sounds wonderful. I look forward to it.
All right. We'll see you then. Professor Fred Watson, Astronomer at Large. Don't forget to visit us on our website. In the meantime, you can do that at spacenutspodcast.com or spacenuts.io. All sorts of things to see and do and buy there. Well, mainly Fred's books, but, there's other stuff as well. Some of it's even interesting. Oh, sorry. Some of it's not. And I think I wrote those books. Never mind. And thanks to Hugh in the studio, who couldn't be with us today because he was stirring the pot around Andromeda, causing all sorts of mayhem. Typical of Hugh. And from me, Andrew Dunkley, thanks for your company. Catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.